Assalamu alaikum. This is your computer science teacher Sir Fawad Akhtar Ansari, and today I will explain you bubble sort algorithm. So basically, what does the bubble sort algorithm do? It pushes the biggest value into the last if we performing ascending to descending order. And bubble sort algorithm can be done using descending to ascending order, but depending on the user requirement. So our requirement in this program is to perform ascending to descending order, and we will perform bubble sort algorithm in our case. And there are two kinds of cases that we consider before doing the bubble sort algorithm. One case is known as the best case, and in the best case the input values are already in ascending to descending order, and when our algorithm executes the program, so it does not need to do effort in organizing on or sorting the values, because they are already in ascending to descending order. So this is called the best case. And the other case is known as the worst case, because in this case input values are not in the correct order. So our program will put all of its effort to organize these numbers into the correct position using ascending to descending order. And there is another thing that we used to count, which is called time complexity. So time complexity occurs when the system is performing or is consuming more power and more logical operations on the bubble sort algorithm, so it also counts. So let's suppose first we just discuss the general concept of the bubble sort algorithm. So you see that there are two rows, one is the value and the other is the index position. So in my scenario, I input I input 5 values, and all these 5 values are random, if you see it over here. And I assign the index position to each value, and my index position starts with the 0, as you can see here. Now when I start my bubble sort algorithm, so one number would be excluded according to the formula, because at the end my biggest number will be pushed to the last position. So after the first step we will not count that number, so we used to call it n-1. n-1 means these are the total numbers. Let's suppose in my case total numbers are 5, and if I put the formula n-1, so we will perform n-1 operation in our pseudocode. So we find the number of elements are 4 here. So I explain you again that why number of elements are considered 4, because after our first pass we will find that our biggest value has been shifted to the last position, so we will exclude this value for the next level. So that is why we used to call it n-1. So we will find our number of elements n-1. In our case I have got n number of values are 5, so 5 minus 1 becomes 4. So what is a pass? Basically we will start comparing for the swapping our values, our input values. So that is why I used to call it pass 1. So let's begin pass 1. So 4 and 7 are in the correct position, we do not need the swapping, so comparison has been done. In the next comparison 7 5, so yes, 7 is bigger than 5, so we will do swapping. In the third comparison we will see that 7 and 2 is there, so 7 is bigger than 2, then we will perform swapping here. And in the next comparison, so we can see that 7 and 3 are numbers there, so 7 is bigger than 3, then we will perform swapping. So first pass has been completed, and you can see our numbers are arranged, and the biggest value, which was 7, it has been shifted into the last position, right? You can see here our sequence, and in our sequence 7 is the biggest number, and it has been shifted successfully to the last position. So pass number 1 has been done. Now let's begin pass 2. Now 4 and 5 will be compared, so no swapping, because the comparison says that 4 and 5 are in the correct order. Next comparison begins 5 and 2, so 5 is bigger than 2, definitely we will perform swapping here. Then next comparison 5 and 3, so we will perform swapping because 5 is greater than 3. Then here we can see 5 and 7 comparison, and 5 is smaller than 7, so we do not need to perform swapping, but we will do comparison definitely. So this is our position, or this is the pass to finish line that we find these numbers. But you see that numbers are still out of order because 4, 2 and 3. So excluding 7 and 5 from our passing, we will start our pass 3. So 4 and 2 we perform swapping because the comparison says that it needs a swapping. Now after this swapping we will see 4 and 3. So 4 and 3 are swapping because 4 is greater than 3. Then here 4 and 5 will be compared, no swapping needed. Then 5 and 7 compared, no swapping needed. So finally we got the finish line, and we see that our numbers have been swapped successfully. Let's go through back and summarize this thing. So if you see, like in the pass 1, we do not need to swap these values, and when we go through the entire process, 7 is in the last position. Now in the pass 2, excluding 7, we will compare these 4 values. So in the pass 2 we compare these 4 values, and in pass 3, when we started pass 3, we see that 5 and 7 are in correct position, so we will not compare 5 and 7. We will not do a swap 5 and 7. Then in the pass 3 we will do comparison of these 3 values, right? This is what our logic says. So the pseudocode we will make according to this logic, but the pseudocode will not be considered as efficient pseudocode because you can see that our program is putting extra effort on unnecessary comparisons. Like here you can see, I explain you here, no swapping. Okay, correct, no swapping here. So why our system is waste its processing power or time to compare these values? So no need to have comparison here, and no need of comparison in this condition here. So you can see that we must also avoid unnecessary comparison in our pseudocode, right? So here you can see another unnecessary comparison. So we must avoid unnecessary comparison that we are facing, because if we do not avoid unnecessary swapping, our code will execute definitely, our program will run successfully, no problem, but the system is putting extra effort on comparison, and these comparisons are unnecessary comparisons, as you can see here. Like, look, there is no need of comparison because 4 and 7 is, it is understood, right? So swapping is happening, right? Swapping is doing great. Now here it is unnecessary comparison, it is doing unnecessary comparison, all right. Our system does not need to do comparison on unnecessary values. Then okay, it is swapping. Then again, why it is comparing these two values? Because these are in the correct order already. So the values which are in correct order, our system does not need to compare these values. So how to avoid unnecessary comparison? We used to call it optimized pseudocode in the bubble sort algorithm, right? So I hope you understood the concept. Now let's go for the pseudocode mechanism. So in the pass 1, how does our pseudocode will work? So in pass 1 we can see that 4 and 7 must be compared, right? But before making the pseudocode, we also find out the area which we used to call temp. Temp is a resting place, or you can say a waiting room for the variables or the integers, whatever you call. So let's suppose 4 and 7 are comparing, alright. So 4 and 7 are in correct order, no problem. Now we go 7 and 5. So what would happen? So 7 will leave the room and it will stay here. And now 5 will go to 7's room and 5 rooms gets vacant. And now 7 will take place in the number 5 room. So you can see that how we efficiently work with our pseudocode. So again, now next in the next pass, 7 and 2 will be compared. So 7 will go again here in the waiting room, and now its room is vacant. Now 2 will go to the number 7 room, and number 2's room is now vacant. Now number 7 will go in number 2's room, and our waiting area is empty, no problem with it. Now same thing will be repeated with the 7 and 3 comparison. So this is how our swapping will be done using the waiting area or waiting room, which we call the temp variable or the temporary variable for the values. So let's start making the pseudocode of it. You may do declaration and initialization in the last, so I am skipping this part. Now let's suppose I use a prompt to show my user what I'm actually doing. So I indicated my user using the print statement that values start with the index position 0. So it will be cleared for the user as well. Now I will use the input prompt to ask the user to enter number of elements to store the values, and it will be storing the number of elements variable. Then I use a loop to count the number of elements that the user will input. Like in our case, if you can see here that we have total number are 5 and number of array elements are 4. So user definitely will input the number of elements which are 4, and it will definitely start from the 0, so it will count. So it will start from the index position 0. So from 0 it will 0, 1, 2, 3, 4, right? So 0 starting from the 0 position, so 0, 1, 2, 3, 4, and it means we have total numbers are 5, and according to the array perspective we have got index position starting from the 0, so it will be 0 till 4. I hope it gets cleared. Now I will ask the user to input the number of input the elements. So in our case, what are the elements? We have got 4, 5, 4, 7 here, 4, 7, 5, 2, 3. So 4, 7, 5, 2, 3, I will input 4, 7, 5, 2, 3. Now what will happen? It will go back up, so it will ask me 5 times to store numbers. Now I will use another loop which is called the outer loop, and the purpose of this outer loop is to count the number of passes that could be 5 or 6 passes. I do not know the number of actual passes, so I use a variable count to pass, and starting from the index position 0 I will count till the number of elements. If the user input number of elements 10, if user input number of elements 7, or input the number of elements 6, so it will go till from 0 to the number of elements. Minus min means excluding, that this is understood that in the last the biggest value will be pushed back. So in the past one we will do the same logic, that number of elements, like we have got 0 till 4, and out of 0 till 4 one number after first pass will be excluded, so that is why we are using -1 formula. Now if you see in our scenario, we input 5 values, right? So depending upon our input values, our number of passes will be generated. So our values are 5, and how many passes did we do? Pass 1, pass 2, and pass number 3. So it depends upon your input values as well. If you input 4 values, or input 6 values, input 7 values, input 8 values, first thing, it depends upon your input numbers, total numbers. Input 5 values, 6 values, right? Second, what is the most important thing? Number of order, right? Let's suppose you have, let's suppose if I say 4 and 7 is in the correct order, and then I say 2 and 5 is in the correct order. So it also depends upon your order as well, because it also affect your number of passes. So I cannot guarantee, and nobody can guarantee, that how many passes will be generated in your bubble sorting. So it depends upon your total number of input. In my case, total number input are 5. And second thing, my numbers order. Okay, what is the order of my number? So in my case, the number of order was pretty simple: 4, 7, 5, 2 and 3. Like, let's suppose if I have got 7 is in the correct position. Let's suppose if I see 7 is already sorted and I have got 3. So number of passes depends upon each case. So I do not guarantee, nobody will guarantee you that how many number of passes will generate. So that is why what do we do here? That is why we excluded our number of passes. So each time our number of passes will be excluded from our swapping, right? So in my case, that I told you that I input total 5 values, and it becomes like total number of elements are 5, so minus 1 becomes 4. So it means I have got total number of elements 4, and in each pass, in each swapping, we will decrease the number of passes, right? So it becomes like 4, and then 4 minus 1 becomes 3. So you saw it here, like how many passes we did. We have got 3 passes, right? This is a dry run of our logic. So number of elements are 5, then 5 minus 1 becomes 4, and then on every time our loop will execute, it will decrease the number of passes, means 4 minus 1 becomes 3, then 3 minus 1 becomes 2, then 2 minus 1 becomes 1. So this is how this formula works. So this is a reason that I use this formula. Now the same logic that I told you in the beginning, that if value is count to swap, so let's suppose I revise this value so you may understood it easily as well. So here I write it 7 and 5, the same thing. Right now I want to swap 7 and 5. So first 7 will be sent to the waiting room, and the 7th position is vacant. Now 5 will go into the 7th room, and 5 room is empty. Now 7 sees that this room is empty now, so it is a place for it. So it will go back there, and the temp variable gets empty. So each time this process will be repeated, right? So this is happening. So you can see that index position 1 is greater than index position 2 in the previous case, so that's why we did the swapping. Now index 2 is greater than index number 3, because 7 is greater than 2, so we will do the swapping. So index 1 is greater than index 1 plus 1, so you may call it here. So you may see it here, we use the same formula. Then we are sending the variable or value to the temp variable, then this will happen, right? Now this will execute next time, so until the number of swapping or number of comparisons done, then our inner loop will close. Then it will go for the outer loop, which is for the passes. When we complete our number of passes, then our loop will be closed, and we will indicate our user that values are now sorted, and then we'll display our numbers. So this program is working perfectly fine. This pseudocode and the program I also checked is perfectly fine. Let's see the testing. So let's suppose array starts with the index position 0 and enter the number of elements to store the array. So number of elements to store the array, I input 4 elements starting from the 0. Now what are the values that we have got? It is 4, 7, 5, 2, 3. So 4, 7, 5, 2 and 3. So now let's see what would happen. Right, array is sorted and we have got the result 2, 3, 4, 5, 7. It is working fine. But if we talk about the time complexity, so computer performed unnecessary comparison in this sorting. So the time complexity matters. If you see as a human that it immediately gives you the output, but behind the scene it did its effort to do this sorting. So we do not want our computer system to be burdenized or our compiler to be burdenized. So we will make this algorithm, we will make this pseudocode more effective, more efficient. And how we can make it more efficient? By avoiding unnecessary comparison. So when we say that we are avoiding unnecessary comparison, so we need to do some changing in our pseudocode to make it efficient, and then we will call it optimized bubble sort algorithms, right? So how do we make our this inefficient algorithm into the optimized bubble sort algorithm? So let's do, how do we do it? So I have made the pseudocode of it, and here in this line of code, in the outer loop, I use a variable swap. So I make it false because by default swapping is not happening, so I consider it that it is swap false, and I use as a boolean variable. So swap is false in the outer loop because we are just starting the counting number of passes. So swapping is not happening here, swapping is false. And then I use swapping here, like swapping becomes true in the inner loop, because in the inner loop we will see that we are comparing the values, right? So if we are comparing the values, and swapping becomes true, in this case, if you can see now that in pass, I think it is pass number 2, pass 3, right? So let's consider this example like pass number 3, 4 and 2. So swapping becomes true because 4 is greater than 2. So swapping becomes true in this iteration. And in the pass 2, you see that swapping is happening here, 5 and 2. So system will ignore this unnecessary comparison, it will not go for that. So it will ignore that unnecessary comparison, it will jump to the swapping values because we are making it swapping true, and it is happening inside the inner loop, right? So here it will perform the swapping, here it will stop comparison of this unnecessary swapping. So no swapping is here, so there is no unnecessary comparison. So our system will avoid this unnecessary comparison, and it will jump to the pass 3. So each time it will happen this situation, right? So I hope you got the concept. So now let's get back to the document, and now you can see that swapping becomes true, and then we will just close this inner loop. Now what would happen, like if there is no more swapping, like if when we go out from our inner loop, we will also check this out that whether the swapping is happening or not. So if there is no swapping left, so we will exit from our outer loop, right? So because we have just get out from the inner loop and now we are in the outer loop, so we will also check that if there is no more swapping left, then we will not iterate unnecessary our program. So we will just get exit from our outer loop, and then our program will jump here on the print statement, and the same thing we will see that we did here. We will get this output, right? We will get the same output after performing the optimized pseudocode. So you will see that there is no difference between the optimized pseudocode and this pseudocode. So what is the reason? Because as a computer takes effort on comparison and swapping, so we are just making it more straightforward that it must avoid unnecessary comparison and focus on the swapping. So we are just making it focus on the swapping, so that is why we use the swapping variable. So by default swapping is here false in the outer loop, right? And in the inner loop we make our swap true, right? When we complete our inner loop, we will check that whether the swapping has become false or not. So if it is false, then we will break our outer loop and go for the print statement. So this is our optimized bubble sort algorithm pseudocode, and I hope you understood it. And if you do not understand, you may ask me on the WhatsApp. I will reply you as soon as I get free. And thank you so much for watching the video. Allah Hafiz.